All right, question 3 from the GRE practice test 1. We're still in this section where we're comparing two quantities, quantity A and quantity B. I'm just trying to figure out which one is bigger, or if they're the same, or if there's not enough information to tell. So this question, it's kind of symbolic heavy, so I think that could be intimidating to some people from the start, but it's really not that bad. The idea is we have these three numbers, x, y, and z. And the only thing we know about them is that x is the smallest, y is the middle one, and z is the greatest. And I'm using those terms smallest, middle one, and greatest a little bit loosely. Like x might be negative 1,000, and y could be 0, and z could be 1. X is the furthest left on the number line, z is the furthest right on the number line, and y is in between x and z. And what we're supposed to be comparing is y, the middle of the three numbers, and x plus y plus z divided by 3. I think the key thing to identify that makes this problem a lot easier is if you're adding up three numbers and then dividing that sum by 3, what you're calculating is the mean of those three numbers. More generally, the mean or sample average, which is often denoted x with a little bar up on top, you say x bar, is equal to the sum of a whole bunch of numbers, so x1 plus x2 plus x3, and so on for however many you have, maybe xn if you have n of them, divided by the number that you have, so n in this case. Using this general formula where n equals 3 essentially gives us quantity A. So anyways, three numbers. If you take the average of those three numbers, is it always going to be equal to the middle of those three numbers? Is it always going to be less than the middle of those three numbers, greater than the middle of those three numbers, or can you not tell? Well, if you're a little bit comfortable with averages, you might realize that you can't tell. It depends on what the numbers are. For example, if those three numbers are 1, 2, and 3, then x plus y plus z divided by 3, in other words, the average of those numbers, which we can write as x bar, would be 1 plus 2 plus 3, which is 6, divided by 3. 6 divided by 3 is equal to 2. In this specific example, quantity A is the exact same as quantity B. They're both equal to 2. But that won't always be the case. Think about if two of these numbers are really small and one of them is really big. So like x and y are 1 and 2 again, but maybe now z instead of being equal to 3 is equal to 9. If I add these three numbers up, 1 plus 2 plus 9 is 12. And if I divide 12 by 3, I get 4 as the average. But note now, quantity A, 4, is bigger than quantity B, which is still just 2. So the answer can't be A, where quantity A is always bigger, nor B, where quantity B is always bigger, nor C, where the two quantities are always the same. My answer must be equal to D. It's worth pointing out, just like we made the average bigger than the middle number in example 2, we can make the average smaller than the middle number in example 3 by kind of doing the same thing we did here, but in reverse. Instead of two small numbers and one large number, pick two large numbers and one small number. So maybe 1 and then 8 and 9. Add those three numbers up, you get 18. 18 divided by 3 is equal to 6. Note that 6 is less than 8. So in this case, quantity B is bigger than quantity A. Either by just thinking about the mean and how it's not always equal to the middle value in the set, or by actually coming up with numeric examples showing that the mean can be equal to, greater than, or less than the middle value in the set, we realize that the answer to the question is D. Again, I should probably be done at this point, but for my math nerds out there, I want to go a little bit further to analyze this in a way that you probably don't need it all for this test, but maybe some of you will find a little bit enlightening. On these comparison questions, sometimes it can be useful to set the two quantities equal to each other, or to set quantity A greater than or less than quantity B, and see what that implies. What I'm saying is, if I wanted to, I could say x plus y plus z divided by 3, in other words, quantity A, is equal to y, quantity B, and see what that ends up implying. Well, let's see, if I kind of mess with this thing algebraically, I can multiply both sides of the equation by 3 and get x plus y plus z equals 3y. I don't know if that really shows me anything. Maybe I could subtract y from both sides of the equation and get x plus z is equal to 2y. That's still not all that useful. Well, what if I solve for y? What if I divided both sides by 2? What that would tell me is that x plus z divided by 2 is equal to y. That actually does contain some information, although it's not really obvious what it is. Remember that when we added up three numbers and divided by 3, we got the average of those three numbers. And more generally, if we add up n numbers and divide by n, we get the average of those n numbers. Over here, what I'm doing is I'm adding up two numbers and dividing by 2. Over here, what I'm doing is I'm figuring out the average of the smallest and the greatest number in the set. The only way that quantity A is going to be the same as quantity B, which is what we started out by assuming here, is if the average of the smallest number and the largest number is equal to the middle number. That's what we saw in example 1 here. The average of 1 and 3 is 2. If the average of the smallest and the greatest number is equal to the middle number, then quantity A will be the exact same as quantity B. But if I replaced all of these equal signs with greater than signs, what that would tell me is that quantity A is greater than quantity B anytime that the average of the smallest and the greatest number is greater than the middle number. That's exactly what we saw in example 2. The smallest number and the greatest number are 1 and 9. Their average is 5. If the average is greater than y, then quantity A is going to be greater than quantity B. Similarly, if you change all the equal signs into less than signs, you'd get example 3. Not only have we figured out that we don't have enough information to figure out whether quantity A or quantity B is greater, we've come up with conditions for exactly when quantity A will be greater than, the same as, or bigger than quantity B. Unfortunately, none of that is necessary for this problem. I just thought it was kind of interesting, so I threw it at the end of the video.